So today we discuss motion combined electric and magnetic field. So that's a very important concept. Is motion combined electric and magnetic field. Okay. So we know what is a magnetic field and what is a magnetic force and electric field and electric force. Now if I combine these, okay, so how the Lorentz force look like that. I combine these two forces. So there is a 3D diagram. Suppose there is a x-axis, y-axis and z-axis. There is a charge, proton, a charge move in that direction, x-axis direction. So velocity in that direction, sorry, y direction. So velocity in y direction because the proton move in y direction. And say the magnetic field in B represent in x-axis. Okay, and now the velocity in y-axis and charge particle velocity in y-axis, a magnetic field in x-axis. So the magnetic force V cross B, so downward direction, that's a clockwise. Okay, that's a downward, that's a B. Okay, and consider that electrostatic force is upward. Okay, so electric field in upward direction. So the force F E same direction. So you see that electric field and electrostatic force both are in same direction, but magnetic field and magnetic force are not in same direction. So they are is perpendicular. Okay, you see that's the difference. Electrostatic force and electric field are in same direction, but magnetic field and magnetic force are in perpendicular. They are mutually perpendicular to each other. So the force we know that is combine these two, that is Q E is a vector plus V cross B. Okay. So now that electric field there's a actually that's the F E and that's the Q times D that represent the F B. Basic Q included that. So E in Z axis. So unit vector of Z axis or direction defined K cap, and Y axis is J cap, X axis is I cap. So E, that's the vector electric field, E the magnitude of the electric field and direction is K cap. Similarly velocity is a vector, so that's the magnitude of the velocity. So magnitude and the direction is y direction. So means a j cap. That's a unit vector. Unit vector actually defines the direction. Okay, unit vector magnitude with a 1, but main purpose of the unit vector is define the direction. And there is a magnetic field B. That's the vector. The magnitude B and the direction is I cap. Okay, now I put these three in force equation. What we get finally? F equal to Q vectorically E, so E K cap plus V V J cap plus B I cap. Okay. Now you see that here a J cap and I cap, cross product between these two, because the E, V, B are in magnitude here. So J cap cross I cap. So J cross I. So J cross I, there are similar the cross product, we get minus K cap. The direction is there is a plus K cap, downward is minus K cap. So there is a plus K, and from origin O, suppose there's a O, downward is minus K. So finally we get Q E vector K cap, and here VB, the very important is VB, and that's the minus K cap. Okay, so here Q E K cap minus Q V B K cap. If I common K cap in both these two, so Q E minus Q V B K cap, that's a force. Suppose the resulting force here, that's the resulting force, say, suppose the resulting force, combine these two force, means combine electrostatic force, suppose combine, and if we combine these two, we get here, okay, say the resulting and combining force be 0, say 0 Newton. So 0 Newton means the electric field in upward direction, so electrostatic force is upward and that magnetic force is downward, Fp downward, but their magnitude be the same, but they are in opposite direction. So they are in opposite direction. So vectorically, that if I added these two vectors, you get a 0. That's not on. That is 0 Newton. That's a 0 Newton. So now if 0 equal to QE minus QV cross B, that K unit vector is not equal to 0, because we know that unit vector K cap magnitude is 1. So K cap is not equal to 0. So from like a equation solving linear equation, that is QE minus QVB equal to 0. So QE equal to QVB, QQ cancel. So velocity, that is equal to E by V. That's a very important equation we derive. Okay, the velocity is the ratio of the electric field by magnetic field. Okay, the very important concept here. The force be 0, as a magnetic field, the force be 0, the velocity is equal to the ratio of the electric field and magnetic field. This condition is used, actually there is a write a note, this is a condition, and this condition pause the video and write down the notes. Condition, very important, can be used to select the charged particle, select the charged particle of a particular velocity. Particular velocity out of the beam, out of the beam containing charge moving with different speed, containing charge moving with different speed. Wait. Speed. And E by V ratio, that's the E by V ratio is called velocity selector. Okay, selector. That's the name. E by V is called a velocity selector. And just V just only depend on E electric field and only a magnetic field. Clear? Next concept, the important concept we discussed, the Biot or Biot-Savart law. That's very important. The Biot-Savart or Biot-Savart law actually help to find to calculate magnetic field due to a current carrying wire. Okay, that's the important law in magnetic field. Some books, someone says pronounce that Biot, or someone say that is Biot. Both are in same. Okay, there are two scientists, Biots or Biots and Savarts. So combine these to get the Biot-Savart or Biot-Savart law. The very important. Okay, clear that concept. Now we discuss. So calculating magnetic field due to current. Calculating magnetic field due to current. Okay, and these are Biot or Biot. You say any one of these, Biot or Biot and Savart law. Biot or Biot and Savart, the two scientists. Okay, they are Frenchmen, and as a name is Biot and Savart or Biot-Savart's law. The Biot-Savart's law actually stated there is a conductor. Okay, a conductor. This is the conductor. Okay, and this conductor carrying current I in that direction. I, and the length of conductor be L. So length is that L, and now we choose a shortest length. Suppose these are called a shortest length. Just these are differential length, that's called dl. Okay, and calculate magnetic field at a point P here. Calculate P here. Okay, so here now that current in that direction, so IDL in that direction, the vector quantity. Okay, now and from this where to point P, the distance or separation between these two. Okay, the I in that direction, P, suppose calculate magnetic field at point P. Okay, so suppose that point P, and that's the distance is R. Okay, so magnetic field, suppose there is a current and that P direction, magnetic field is thumb rule. Now current represent the thumb, and magnetic field, that is a representation of calculate magnetic field at point P, and the gap is R. The separation between point P and DL is R, and angle between these IDL and R is theta, and that's the R cap direction. B is the DB is R cap direction. Okay. Now the Biot-Savart's law states that dB. Now suppose the dB. Okay, if I say the magnitude of magnetic field, okay, the dB that is equal to mu 0 upon 4 pi, that is I dl sine theta by r square. So here we see that the Biot-Savart's law states the magnetic field is directly proportional to the I. Okay, then proportional to the I is more current. So here the B directly proportional to I. Okay, so more current means more magnetic field, and B also directly proportional of dl, the length. Okay, or the length, and dB or B is inversely proportional the separation between the square of separation between these 2 points, means the dl to at point P. And if I combine these two series and we get this. Okay, so that's the magnetic field, that's why the cross product. There's a, if say the magnetic field is a scalar field, so that's a dot product. Otherwise, B is a vector, that's why the cross product, so ideal sine theta. And what is the mu zero? Mu zero, that's the permeability of free space. Okay, so mu zero, that is equal to the value is 4 pi into 10 to the power minus 7. So SI unit is the mu zero, dB magnetic field, there's a Tesla. So here dB times r square, Tesla meter square, and I by down ampere, and dl, that's the length is meter. So cancel these two, Tesla meter per ampere. Okay, that's the SI unit of permeability of free space. Free space. Okay, that's a constant term. Now, if there's a magnitude, obviously, if I put a vector, dB is a vector, so that is mu 0 by 4 pi is a constant term, and here is I dl, and there is a r vector by r cube. Why? Because that's the separation, that's the, if I that some books reference that is the r, and some books are like represent that dB, that is mu 0 by 4 pi. So I dl, that's the r cap unit vector, that's the one, obviously that's the r square. Both are true. If I cross product here, that confusion is not create, because that mu 0, both are true. Okay, both are right, because mu 0 by 4 pi, because we get I dl r sine theta cross product by r cube, so cancel these to r square. This is also true, and these also true. Mu 0 by 4 pi I dl, the r cap is a unit vector, so the magnitude is 1 times sine theta by r square. These calculation also true. Okay, if you choose any of these, both are right. Some books I think write that equation or vector form of the Biot-Savart law, or some books are referred as. Both are right. There is a Biot-Savart law in vector form. So Biot-Savart law actually help us to calculate magnetic field. Actually help to calculate that magnetic field, and that's the r cap is the direction of the magnetic field. Okay, r cap is the define the direction of magnetic field. So we know that direction represents the unit vector, so that's why I choose the unit vector with the 1 in this case. Okay, that's the Biot-Savart law. And here the Biot-Savart law help to calculate magnetic field surround the current carrying wire. If you want to calculate the magnetic field at here point, suppose P dash, with the help of Biot-Savart law. Okay, there's a small differential length dl, that's very important. Okay, now here there's some dependence on the magnetic field, and there is some electric field. There is some similarity or some difference here. The magnetic field and that also the electric field means that suppose the Biot-Savart law or Coulomb's law, Biot-Savart law for magnetic field and Coulomb's law for electric field, both are satisfy inverse square law, the 1 by r square. Suppose here the Biot-Savart law for magnetic field, Biot law for magnetic field, for calculating magnetic field. And here the Coulomb law in electric field, like that. Coulomb law in electric field, because the F equal to Q times E, and that E equal to F by Q, and the Biot-Savart law we get from equation here. Now both are dependent inverse parallel, because the F equal to 4, okay, that is equal to some constant 1 over 4 pi epsilon naught, suppose Q1 Q2 by R square. So F is inverse square their separation, okay, the distance, and the magnetic field obviously dB, that is 1 over R square, and this R is the gap between where, okay, moving charge where to that point, and here the separation is 2 charge. Actually the static charge produce an electric field, here is a moving charge, so that's why the where is needed. Otherwise here is a static, a single charge produce an electric field, but here is a more than one charge, more than, not only one, is a huge number of charge flow with respect to time get current, and that current produce an magnetic field. Similar like that is charge produce a magnetic field, both are satisfied, okay. Now there is a similarity, and another similarity is both are vector field. Vector, these also a vector field, okay, and the vector field, and one thing is defined is that B, okay, that's a vector produced by a vector source, be produced by a vector source, IDL. The magnetic field produced in for vector source, but the electric field produces scalar source. Here the electric field produced by scalar source, only Q, a single, a charge, a scalar quantity. Now another important there is some difference, or that one difference is now the magnetic field, right here, right here, the magnetic field is a perpendicular to the line. Magnetic field B is perpendicular to the line, but electric field, okay, is a parallel to the line joining between two charges. Line, there's a current passing through the line, or where current through the where. Now here another important, there is some constant similarities, okay. So here the permeability of free space is the mu 0, and epsilon 0 is the permittivity of free space. Permittivity of free space, that's the permeability of free space, okay. And we know that if I multiply these two, these four came magnetic field and these came from electric field. If I multiply these two, okay, that's very simple. If I multiply mu 0 and epsilon 0, what I get? So suppose the mu 0, mu 0 by 4 pi, and the 4 pi times epsilon 0. Now mu 0 by 4 pi we get, that's mu 0 by 4 pi, you get 10 to the power minus 7. Get 10 to the power minus 7, and 4 pi epsilon naught. 1 by 4 pi epsilon naught, that is equal to 9 into 10 to the power 9. And this is a reciprocal of this, means 1 by 9 into 10 to the power 9. Okay, now I drop down here 9 into 10 to the power 9 plus 7, that is 16. And that's equal to, say that 3 into 10 to the power 8 whole square. And we know that 3 into 10 to the power 8 is the speed of light. Speed of light. So here 1 by c square. So final expression we find the mu 0 times epsilon 0, that's equal to 1 by c square. That's very important. Okay, there is a speed of light. So, and the magnetic field, there's an electric field, and the light is an electromagnetic wave. There is similarities. Okay, and light is EM wave. We know that. Okay. Okay, clear? That's some similarities between combine. If I combine these two, electric field and magnetic field, and what we get. That's a very basic way. Okay, clear? And the Biot-Savart law is very important to calculate magnetic field. Okay, Biot-Savart help us to calculate or finding magnetical sounding of a wire, and this wire is very important. Current passing through that wire. So because the moving charge creates a magnetic field, clear, and the static charge creates an electric field. That's the basic core concept. Okay, so today in the class here, if any doubt, always ask in comment section. I will try to give the answer. And very important, next class we discuss application of Biot-Savart law or Biot-Savart law. So today in the class here, thank you.